Hi students, in the last lecture we discussed about two variable, three variable Boolean function and how to minimize those Boolean functions using Karnaugh map. In this lecture I am going to explain about the four variable K-map. For variable K-map, the four variables may take a function x, y, z, q or w, x, y, z. That four variable K-map has maximum of 16 minterms. Those 16 minterms can be represented with a letter m suffix j. The j start from 0 to 15. Those minterm representation of m0 to m15 can be assigned in a square box in the K-map. Of those 16 minterms can be arranged in a square box according to the gray code order. M0, M1, M3, M2, M5, M4, M5, M7, M6, M12, M13, M15, M14, M8, M9, M11, M10. And the map has these 16 squares. And what are the possibilities of adjacent squares in this entire 16 squares of K-map? When we see this K-map box, this is the K-map box. In this entire box, we can divide it into 16 square boxes and assign minterms M0 to M15 according to their order. While assigning those K-map, while assigning those minterms, you must follow the reference order of a function. A function w, x, y, z means you can start with a w, x, y, z order. And then what are the possibilities of adjacent squares? We know that adjacent square, a square it is, this square, its adjacent is maybe in horizontally m1, maybe vertically m4. And this is simple one just nearby adjacent. So how many adjacents are possible in the 16 variable K-map? We can have the adjacents as maximum of all ones in the Karnaugh map. If any Boolean function, the listed all variables, like all minterms, when all minterms are listed in the Boolean function, we can take that logic symbol 1 to arrange those all minterms. So all ones filled with these 16 square boxes. In this case, we can consider all ones, all are adjacented, so that minimized entire variables minimized into single Boolean logic 1. The output is 1. Similarly, there is another way. For example, 16 possibilities. One way is 16 possibilities. 16 minterms are there. In such case, your output will be, what will be the output? And the second priority, this is the highest priority. The next highest priority is there any 8 ones? That 8 ones can be marked in like a rectangular form of this one, or rectangular form of this one. In this way we can represent it. So you can take any 8 minterms. These 8 minterms are considered as one group. These 8 minterms considered as one group. These two middle, these two considered as one group. And what horizontally we can consider as this 8 if it is possible, this 8 if it is possible, this 8 if it is possible. And also the special case is we can have 8 is this 4 and this above 4 also they are adjacent to each other. This 4 above 4 and below 4 also adjacent to each other, so that we can combining those 8. So in this way we can combine this horizontally, vertically, vertical 8, 1, 2, 3, 4, and horizontally 8. In this way also we can consider the 8 minterms are adjacent together. The shape of these are rectangular shape for the 8 minterms to be adjacent together. And then third priority is we can make them like we can make them 4 adjacent of minterms. We can have 4 adjacent minterms. So how can we identify those 4 minterms? So if we in this 16 square boxes, what are the possibilities to 4 adjacents? M0, for example, M0 is the starting one. We can collect M1, M2, M3. This is one way. And take the reference M0. We can collect these 4 adjacents. These 4 are also adjacents. Suppose if I am taking the origin minterm is M5, start with M5. We can cover horizontally. We can cover vertically if it is possible, all ones in the left side and left and right side, and or top and bottom side. So 4 ones are there. Otherwise, in center we can make one square. In this way also we can cover if it is all ones are there in M5, M7, M13, M15. Otherwise, there is also possibility to cover in this way. So likewise, we can have either square or horizontally 4 ones, vertically 4 ones. Next priority is we can make the minterms pair. This is squared. So pair, how can we make pair? We can horizontally take 2 minterms, vertically take 2 minterms. Okay. So likewise, in the last priority, if there is no redundancy, there is no neighboring adjacency, so we can have direct 1 as a circle, and then we can take the all variables. Now we will see this kind of possibilities of adjacent squares. We can go through the simplification process. While go through the simplification process, we can apply the maximum possibilities, highest priority of 16 ones in the 4-bit K-map, and 8-bit ones, 8 ones are there in the K-map. The next priority is 4-bit, next priority 2-bit, nothing but pair, and then finally single bit. So in this 4-bit Karnaugh map, if you take a function f of x, w, x, y, z, this is the function, and the minterms represented with the summation. This kind of Boolean function, what is the corresponding Karnaugh map is, it has a 16 square boxes. The map, we can assign the values in a horizontally 2 variables and vertically 2 variables, because this is the way we can make the Karnaugh map. For 4 variable Karnaugh map, we can divide it 2 variables in horizontal, 2 variables in vertical. In contrast, in 3 variable Karnaugh map, we can take 1 variable in horizontal and 2 variable in vertical, or we can take 2 variable in horizontal and 1 variable in vertical direction. So, but in a 4 variable, we create a square map in which 16 square boxes, which represents minterms. So I am taking a K map with the representer the variables wx in horizontal and yz in vertical direction. In this vertical direction. So horizontally, we can take wx. The assigning of logic values for this wx we can follow with the gray code order. The gray code of binary 00 is nothing but 00, and what is the gray code for 01? Nothing but 01. What is the gray code for 10? Nothing but 11. And what is the gray code for 11? Nothing but 10. So we can take this order 00, 01, 11, 10. What does it mean, this 00 in horizontal? Which means w, we can take w bar x bar. What does it mean? What vertically 00 means y bar z bar. So remember that when 0 is nothing but complemented and 1 nothing but uncomplemented variable. So we can see here. What is the first midterm representation in the box? Horizontal first row 00 means w bar x bar, and vertically first row 00 means y bar z bar, so that we can concatenate these two variables, these two horizontal and vertical variables, so that we can get a 4-bit midterm which represent with w bar x bar, y bar z bar. This is nothing but a 4-bit 0 in decimal representation. So in a logical values, in a binary representation, w bar means 0, x bar means 0, y bar means 0, z bar means 0, so that its corresponding decimal number is 0. Its corresponding decimal number is 1. Its corresponding decimal number is 3. Its corresponding number is 2. So 2 can be represented with 0, 0, 1, 0. So in decimal number we can represent with 0, 0, 1, 0 is nothing but 2. So likewise we can easily remember that decimal number. That's why we represent decimal number also. So 0, 0, 1, 3, 2. Only the 3 is number is shifted. 0, 1, 2, 3. 3 is just before 2. And 0, 1, 3, 2, 4, 5, 6, 7, 7, 6, 8, 9, 11, 10, 12, 13, 15, 14. Likewise, we can assign those by decimal numbers, so that we can easily identify the given Boolean function in terms of summation of numbers, decimal numbers, so that easily we can identify. We can put that mark 1, logic 1 in the corresponding box. So in this way, this is the 4-variable K-map. How to draw the K-map and assign the minterms and then place the logic values. Now it is required to remember a 4-variable K-map. What if all minterms are there? All minterms are listed in the K-map Boolean function. Then place all ones in the 16 square boxes. Then 16 adjacent square boxes which represent a function is equal to 1. By default, the answer is 1. Suppose 8 adjacents are there. And the 8 adjacents are there in the 16 square box. We can minimize that 8 adjacent square grouped into one box, and your resultant literal is 1 literal. 1 literal. And 4 adjacents are there in the 4-bit K-map. 2 literals result in 2 literals. 2 adjacents are there, 3 literals. 1 adjacent are there, 4 literals. So that n number of variables are there, n minus 1 literals. So this, when we remember this one, so while creating the 8 1 box, 4 1 adjacent box, 2 adjacent box, 1 square box, then its corresponding letters, so that we can easily identify the Boolean expression. Let us say, to clarify this, to identify this 4-variable K-map, we can have some simple example. Simplify the Boolean function, a function w of omega, a w x, y, z. What are those minterms represented in one way is sigma of 0, 1, 2, 4, 5, 6, 8, 9, 12, 13, 14. Or otherwise, can also represented with the minterms like M0 plus M1 plus M2 plus M4 plus M5 likewise. So when directly given this kind of numbers, digital numbers in a summation, form of summation, we can take the K-map, map box, and then place those minterms listed in the function. We can assign the logic 1 for those minterms and assign 0 for the rest of the minterms. So it is very easy to place the minterms, and then we can perform the process of simplification. If you see here, so it is a 4 variable K-map. We can prefer a square box. K-map is a square shape, and take the 2 variables in horizontal and 2 variables in vertical direction. In a horizontal and a vertical direction. We can separate with this line, and in horizontally we can take omega wx, and vertically we can take yz. So in order to get 16 square boxes, we can take 4 lines, 4 boxes lines in horizontal and vertical. So we can take easily we can take represent with the binary values for omega x 0 0, 0 1 row, 1 1 row, 1 0 row, 0 0, 0 1, 1 1 row, 1 1 column, 1 0 column. So what are the minterms which are listed in the function? 0 0. How can we identify 0 0? The digit number 0. The 0 in which represents 4-bit 0 0 0 0. We can also represent in minterms product representation w bar, x bar, y bar, z bar. So how can we follow the order, reference order? Start with w. W bar, x bar, y bar, z bar are 0 0 0 0. Start with w. So 0 0 wx and y 0 0. So 4 zeros we can represent 0. In decimal number we can represent 0. That decimal minterm we can have include 1 because which is listed in the given function. Next 1. So it is better to represent first we can represent the square box in decimal number 0 1 3 2 4 5 7 6 8 9 11 10 12 13 15 14. So wherever the number in the listed in the function we can put 1 0 1, so we can have 1, and 2 4, 2 is there, 4 is there, 5 6, 5 is there, 6 is there, 8 9, you can have 8 9, 12 13 15, 12 13 sorry 12 13 14. So here by placing these logic ones for corresponding minterms, what is the next step is marking highest possibility of shape of the adjacents. Is there any 16 ones, 16 square boxes having ones? No. What is the second highest priority? Having 8 ones. Is there any 8 ones in horizontally or vertically or square shape? Actually there is no square in the 8. So horizontally or vertically. So there is a one possibility. So in order to cover this minterm, this first minterm which has adjacents, the shape is 8 ones. This is the one. So that is 8 ones having adjacents together, so that we can cover all 8 ones. What are the remaining ones have left? The right side 3 ones have left. How to cover 3 ones? If there is a 1 is there in the last box, then we can easily cover that other 8 and left side and right side corners. But it is no 1 is there. So these 3 ones, how can we cover? Is there any possibility to cover 8 ones? No. Is there any possibility to cover squad? Quad? That a quad is possible. How to get that 4 ones? So this 4 ones can be connected like this. This is 2 and this is another 2. So these 2 are also adjacent. This is number 1 and this is number 2 quad. So it is also remember that the left row or left column of 2 binary ones also adjacent. So the remaining one is left. So how to cover that one? By combining 8 ones or by combining 4 ones and then 2 ones. Is there any possibility to combine 8 ones? No possibility. Is there any combining 4 ones? Yes, it is possible. In order to cover this one, we can have quad is possibility. Highest is quad is possibility. That quad is, this is the quad. That quad is, in order to cover this one, we can have a quad. These 2. This is third. Now we can write down the minimized simplification process. How to find out the simplification process? First take the first 8-1 box. So in the 8-1 box, horizontally cover all variables wx, like w bar, x bar, w bar, x 0 0 0 1 1 1 1 0. So when all possibilities in horizontals are covered, they cancel to each other because they are adjacent to one another. So horizontally all are cancelled. So no need to take variable. In vertically, there are 2 columns, 0 0 column and 0 1 column. So what are the common logic value or common variable in the first 2 columns? Is 0. 0 means y bar. So we can take the minimized function f is equal to, first is y bar plus, it is a sum of product representation, we can take plus, and take the second quad, like second box. How to take the variable in this box? Horizontally, what are the common variables? Vertically, what are the common variables? Horizontally, what are the common variables in the 0 1 and 1 1? 1 is the common term. So in this one, the 1 is common. So 1 means here x. What is the common in the same square, second square in vertical direction? This one and this one. So 0 0 1 0, which one is common? 0 is common. Second variable 0 is common. 0 means z bar, x z bar. And the third box we can represent with the third box. Horizontally, first and second row, what is the common variable? 0 0 0 1. 0 is the common, means w bar. W bar is the common variable, common literal. And vertically, first and fourth column, 0 0 1 0. 0 is the common, nothing but z bar. This is the minimize Boolean function. First variable, one single variable because due to 8 ones have adjacency, and second and third quad, 4 variable, 4 square boxes adjacency. So it will come 2 variables. So that y bar plus x z bar plus y bar z bar is the answer. Minimized Boolean function for 4 variable. Next we will move to prime and essential prime implicant. When we see this prime and essential prime implicant, we can take this, identify that prime implicant and essential prime implicant. Essential prime implicant is the implicant, one implicant or one mentor or group of mentums, adjacent mentums. While in order to cover that one, it won't cover with any other implicants, any other prime implicants, then it is said to be essential prime implicant. One prime implicant is not covered with the other prime implicant, then it is called essential prime implicant. So we will see that one. Take the 4 variable table. Wx, yz. So 00011110, 00011110. We know that we noted that all the boxes numbers. So it is a 0. We can mark 1, 0, 0, 1, 3, 2, 2 is there, 3 is there, 4, 5, 5 is there, 7 is there, 8, 9, 10, 11, 11, 10, 12, 13, 15, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we can have 5, 10, 11. So 11 ones are placed. So here, when we see this here, if you mark this one, this 4 ones square, and if you mark all 4 corners also adjacent together. So this square box, this quad, this 4 corner square box, they are prime implicants, but they are not coincident with, they are not combined with other one. Then they are called, these 2 prime implicants are essential prime implicant. Essential prime implicants. So in order to cover the remaining left ones, we can cover like in order to cover this one, we can take any 4. Here it is also 4 square possibilities. So here we can cover this 4, this square to cover these 2 ones, and in order to cover this one, we can take this one. So as I said earlier, while performing the simplification process in the K-map, there are many ways to minimize the Boolean function. The user can choose which way we can prefer to minimize the boxes, but follow the rules that to pick up the like pair, 4 quad, and 8 ones and 16 ones. So these are called prime implicants. K-map with a don't care entries. What does it mean that K-map with So now we'll move to the 5 variable K-map. 5 variable K-map. Up to now we will discuss with the 4 variable K-map. Now we will discuss about 5 variable K-map. How to do the 5 variable K-map means. So in this 5 variable K-map, we can take the 5 variables in the map and create 2 power 5 32 boxes is one way, but it is somewhat difficult to understand. So the other way is to take the 2 4 variable K-maps with the first variable with common for both 2 variables. BCDE is the 4 variable K-map. Another BCDE is the 4 variable K-map. Take the A is equal to 0 for first 4 variable K-map and take A is equal to 1 for second 4 variable K-map, so that we can minimize the Boolean function very easy by following the 4 variable K-map. So let us see now how to find out the 5 variable K-map. 5 variable K-map by taking the 4 variable K-maps. So let us take the 2 4 variable K-maps. I am taking two 4 variable k maps. Two 4 variable k map, another 4 variable k map. What are the variables I am choosing in the 4 variable k map is B, C, D, E. So we can take among the B, C, D, E, we can take B, C in horizontal and D, E in vertical. It is a 4 variable k map. Another 4 variable k map with the same variables B, C, D, E. But in order to get 5 variable k map, I am taking this box is nothing but A is equal to 0, and this box is nothing but this 4 variable k map is nothing but for A is equal to 1. So when we see even in the table also, in order to get that 5 variable truth table A, B, C, D, E, so if among 16 possibilities consider that A is equal to 0, then follow the 4 variable table 0, 0, 2, 4, 4 ones. The next 16 possibilities, again it will repeat 4 zeros with 4 ones by combining the fifth variable A is equal to 1. This among 6 ones in the 16 variables, 16 possibilities, 16 zeros in the 16 possibilities. So that we can take the 4 variable k map to create 5 variable for A is equal to 0, and then B, C, D, E 16 possibilities. For A is equal to 1, B, C, D, E 16 possibilities. So we know that first 15 numbers placed in this 5 variable k map 0, 1, 3, 2, 4, 5, 6, 7, 8, 9, 11, 10, 12, 13, 15, 14. When A is equal to 1, we can take A is equal to 1, which is nothing but 1 0 0 0 0 means 16, 17, 19, 20, 21, 22, 24, 23. We can have 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. So 1 1 1 0 0 1 16 17 19 18 20 21 23 22 24 25 27 26 28 29 31 30. So in this way we can take the numbers. So now whatever the given terms in the function, place the ones in the function, then we can make that a minimized process. What are the numbers given? There are 6 numbers in the first square box, first 4-bit k map 0 2 4 6 9 13. These 6 numbers belongs to A is equal to 0 4 variable k map, and 21 23 25 29 31 are belongs to these 5 terms belongs to A is equal to 1 4 variable k map. Place place corresponding logic 1 to those minterms which are listed in the function. 0 to 469. 0 to 4 6 9 and then 13 21 23 25 29 31 21 23 25 29 31 this one. So if you see this placed after placing, then we can easily minimize the function. I am taking a fresh 4 variables square boxes so that we can easily identify. B C D E B C D E. This is A is equal to 0. This is A is equal to 1. Now 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0 1 0. Whatever the boxes represented with the 1 4 13 19 6. Now how to identify the shape of the adjacents in the 5 variable K-map. Take the all ones, 13 ones, like 0 to 13 ones means 32 ones are there in the boxes. No ones are there. And the next priority is there any 16 ones in A is equal to 0 box, A is equal to 0 K-map and A is equal to 1 K-map? No, 16 also not possible. Now we will take 8, next we will take 4, next we will take 2, next we will take 1. In order to pick up those shape of the square boxes of adjacents of minterms, we can identify these 2 K-maps. And one more thing is here we remember is when we take a minterm 4, the minterm 4 is also adjacent to minterm 20. Minterm 0 is also adjacent with the minterm 16. Is there any 1 in the 0 square box and 1 in the 16th box? They are together adjacents. They are together like a pair. If 17, 1 pair, 19, 3 pair, 18, 2 pair. So they are adjacent. So when we feel that whatever the number in the first row, first one, the second box also first row, first one are adjacents. So we can feel that they are adjacent, so that now we can join the numbers. Here, the most important thing here, 13, 9. 13 is the adjacent with the 29. In the second box, A is equal to 1. 9 is the adjacent with the 25. So they are adjacent together. So we can take that one. If this is pair, this is pair. So they are also adjacents. Here adjacent and here also the same box. Then we can have 4 ones adjacents in the second box. And then we can have pair in this box. Sorry, I'm representing this here 7 6. So in the problem it is 6, so we can place that 6. It is represented here. Sorry for that. And then it is also a pair. How many number here now? Here it is 1. These number like 13, 19, 39, 29, 25 are, they are combining together. They are like 1. This is one box. This is another box. Sorry. So here we can take 4 ones. 4 ones. 1, 2, 3. There are 3 minimized Boolean functions. First we will focus on common pair. F is equal to, what is the a pair is which is available in this, A is equal to 0 and A is equal to 1. These are the 1. So here horizontally we can consider that horizontal, what are the common variable in BC? B11 and 10. 11, 10, which is the common variable, 1 is the common value, nothing but B. So here it is B in horizontally, and vertically we can take vertical. What is the vertical? D bar E. This is the D bar E. D bar E. But here the same pair is available in A is equal to 1. So 1 is the same 3 variable, the minimized 3 variable for this pair for B D bar E in A bar box and B D bar E in A is equal to 1 box. So here it is, this one is common. When this term is common, A plus A bar is inside the box, and according to theorem A plus A bar is 1. So that we can cancel A and A bar term, we can take the 1 B D bar E only, because this pair the same place in the A is equal to 1 box, so that we can consider one thing, B D bar E only, because A is equal to 0 and A is equal to 1 are cancelled together. Second minimized function. Next, if you take this square box, if I take this square box, what is the minimized function? Like and horizontally 0, 1 and 1, 1. What is the common variable, common term in the common number in the 0, 0, 1 and 1, 1? 1 is the common, means like B bar C, B C, C is the common. We can take C is the common. And vertically D bar E and D E, E is the common. So we can take E. In which box it is? We can find out this box. Which box in the 4 variable came up? A is equal to 1 is the box. So we can take A is equal to 1 means A. ACE is the answer for that one. Next we can finish this second and we can finish first, and now we can take 3. What is the horizontal variable? B bar, C bar, B bar C. Which one is the common variable? B bar. So B bar is the common variable. And what is the common variable for vertical direction? D bar, E bar, D E bar. So D E bar is the common variable. So E bar. From where we can pick up this for A is equal to 0 box. A is equal to 0, 4 variable came up. So we can take A bar, B bar, E bar, and ACE and B D bar E is the minimized Boolean function in the 5 variable K map. So it is very important to take 2 4 variable K map, and then one is A is equal to 0, another one is A is equal to 1. Then we can follow the steps and then minimize the function. Next, finally, simplify the Boolean function using the don't care condition. What does it mean, that don't care condition? So far we have discussed how to minimize the Boolean function by considering the minterms which are listed in the Boolean function. Suppose some users require that design some application in that the user cannot be specified some minterms, or some problem is unspecified with the combination of inputs, combination of minterms. So whenever that unspecified minterms are there in the given Boolean function, those are considered as here is don't care. So while performing the processing of simplification, we can consider of those minterms which are not mentioned, which are uncovered in the unlisted in the Boolean function, they have taken as don't cares. So earlier, whenever the minterms listed in the Boolean function, we can consider as logic 1 in the K-map, and which are not mentioned in the Boolean function, we can consider as logic 0. But in this case, they have specifically mentioned that those specified minterms have not uncovered, not specified. Those are considered as don't cares. They have specifically mentioned that these are don't care, whether it is they are logic 1 or whether they are logic 0. So we don't bother about it. We can consider as either 0 or 1. So while preparing the Karnaugh map for the function f is equal to wxyz with the minterms 1, 3, 7, 11, 15, we don't care about what the 0 minterm is, what's the 2 minterm is, what's the 5 minterm is. In earlier, the remaining all values of other than 0, 3, 7, 11, 15 all are logic 0. The 0 specified in that square box. But here we can specify, whether it is 0 or 1, we don't know, but we can take that one is don't cares. So how to make the K-map? The only thing is, so the assigning value of those don't care values of 0 to 5 in the problem, we can assign values lies between 0 and 1. That can be represented with the x, represented with the cross. The cross nothing but don't care. So while including the don't care in the square boxes, so preparing the same procedure, but here it is don't care considered as either 0 or 1. If you want to prepare adjacent to 1, x treated as 1. If you prepare PYS K-map, we can treat it as x. So that's why we can take x as, while combining the adjacents, we can take the x as a 1. So take the 4 variable K-map, very easy. This is the 4 variable K-map. We can take wx in horizontal, yz in vertical, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And we know that how to remember it's the all square boxes 0, 1, 3, 2, 4, 5, 6, 7. So where it is the 1? Here it is 1, 0, 1, 3, 2, here it is 3, 4, 5, 7, 6, 7 is there, 11, 15, 8, 9, 11, 10, 15, 12, 13, 15, 14. Likewise, we can make this one. What are the don't cares? 0 to 5. 0 is the one don't care. 2 is the another don't care. 5 is the another don't care. So our aim is to cover all ones. In order to cover all ones by following 16 one adjacent boxes, 8 one adjacent boxes, 4 ones or 2 ones, we can use those don't cares, but we cannot cover. It is not required to cover all don't care the x square boxes, but our aim is to cover all ones. So in order to cover all ones, what are the possibilities? Is there any all 16 ones? No. Is there any 8 ones? Even we can include don't care? No, not possible. So but we can have 4 ones are there. In the 4 ones we can have the shapes either square or vertical 4, horizontal 4. So here it is possible is to cover this ones, we can have this vertical shape of 4 ones. And how many remaining ones are there left? 1 is there. In order to cover that one, again check with 16 1, 8 1, 4 1. So all 16 8 not possible, but 4 ones are possible by considering don't care. So by considering don't care, we can consider this one, so that we can minimize the maximum number of literals. So there are two boxes, one is vertical one and then square with don't care. So then we can minimize the Boolean function. F is equal to, take the first row, this one is the first, this one is the second. So this horizontally all variables are covered. All variables are covered, then all are adjacent together, cancel together. So no variable comes in the horizontal. What about the vertical? 1 1. 1 1 means YZ. YZ is the answer for this vertical box. Then square box, second one. In horizontally 2 rows covered or vertically 2 rows covered. What is the common variable or common value in horizontal? 0 0 0 1. 0 is the common, means W bar. 0 0 means W bar X bar. 0 1 means W bar X. W bar is the common. And then vertically 0 1 and 1 1. So 1 is the common, nothing but Z. This is the minimized Boolean function, even including the don't care. So the main purpose of don't care is some applications not unspecified input combinations of minterms considered as don't care by marking X in the K-map. By marking X in the K-map and including those don't care while preparing the processing of simplification using boxes. So then we can minimize the Boolean function. This is the K-map with like 4 variable, 5 variable, and even with the don't care. So even the 5 variable also we can consider don't care. We can mark the don't care in the 2 4 variable boxes and treat it as that don't care with along with one's adjacents. So this is all about don't care entries in the K-map, 4 variable and 5 variable K-map. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.